Good morning, good evening, good afternoon, wherever you're hailing from. Welcome to another episode of In the Clouds with Red Hat Leadership here on OpenShift TV. I am Chris Short, executive producer of OpenShift TV, and today we're joined by the one and only Clayton Coleman, who we were joking about earlier, whose job here at Red Hat has become what is the future of cloud? What is the future of compute? So you're kind of the architect in charge of looking forward, and you're a huge Kubernetes contributor, obviously, but what is the future of compute look like? That doesn't sound like a hard problem to solve or anything at all like that.
Well, I mean, I don't know if you have ads on this, Chris, but we're going to draw this out as long as possible so that we can get a bigger and bigger audience as the word goes out that we're gonna drop some knowledge about the future of computing. In all seriousness, it's funny. I worked on OpenShift for 8+ years now, just about, and that whole time, the mission has evolved, right? It's making developers happy, giving operations teams something, right? It's kind of everybody loves running applications. You got operations teams that are in the weeds, and we went from, manually copying things on, floppy disks and moving them to servers to, crazy network file system hacks back to SSH, distributing apps. Like, I remember early days of Ruby and, Ruby on Rails. It was, Capistrano was the hottest thing, and it was using FTP sites to upload your website. And, we keep getting all these better and better tools. OpenShift rebased on top of Kubernetes. Kubernetes is 7 years old now, 6 years old.
Yeah,
It just goes to show like how long we've been doing it, that you have to think about exactly how long it's been.
2015, right? I thought it was 2015. Was it 2015 or 14? I forget.
It was. I can never remember whether we went GA in 2015, which would mean it was 2014, or whether we started. So
that's the problem, right? Like, when was the flip switched right thing? Yeah.
Right. And so like 5 years in, 6 years in, Kubernetes is successful. Containers or something that's kind of, and not everybody uses containers today. You might not know you're using it. If you're in a big company, you very well might be. You might still be using VMs. You might be using, serverless. You might be, still stuck in the old world of you don't even have like great deployment experience, or you might be right on that cutting edge. A lot of what I've been thinking about is, okay, what can we take from what's been successful, kind of look at all the problems people have, stitching this stuff together. What are the kinds of abstractions that can move the discussion forward? So like Kubernetes is a great example, because there's a lot of interesting concepts in Kubernetes about what I call like application infrastructure that's programmable, right? Yeah. So, you got services. A service, doesn't have a whiz bang list of features, 10 miles long. No. You got to go to Service Mesh, or go to one of the API management tools for that. But it's just enough that most people can depend on it. When you have that in place, you can start building stuff on top of it. Even Service Mesh actually relies on services, right? Obviously, from the name. So you keep building up this level of technology and abstractions. Are there other abstractions that we're not thinking about? And this is one that I've been spending a lot of time thinking about. Is we've been really single cluster focused in Kubernetes.
Yes.
And a lot of people out there have come up. I mean, there's plenty of ways to deploy to multiple clusters. One of the things that I'm spending a lot of my time thinking about, that I think is going to be a really big part, is what are the parts of the Kubernetes abstraction that you can kind of lift up and use together? Because we took machines and we put them into a cluster,
right? And
then we came up with abstractions that didn't care about machines. So what are the abstractions that take clusters and make us not worry about clusters? And it's probably going to be different abstractions. What parts of it are the same? What projects do people already have out there, right? There's been a lot of work on federated service mesh. A lot of manual stuff. There's a lot of work on inner connectivity between clusters on services. Everybody kind of has their own way of gluing this stuff together. Red Hat has a couple projects, all the way from the lowest levels, working in the community with Submariner, all the way up to the Scupper project, which kind of lets you have a virtual application network, and you can go even lower. You can set up your clusters so that everything can talk to everything else. I think it'd be really awesome. And I think this is something that's a big focus for us, is can we make that easier? in the community
Yes.
and with standard, standard patterns,
Right.
so that most people most of the time don't have to think about it. That opens up new doors for new types of developer experiences, right? Like if you stop kind of caring what cluster you're running on,
Right.
maybe local development to staging to production, we can take and make better abstractions around.
Right. So we still have that problem of like dev, test, prod kind of scenarios, right? Like, is this cluster the same as, all the other clusters? And people are saying, okay, multi-cluster management is, a thing we need to worry about, which is so fascinating to me because back in like 2016, 2017, we were talking about big clusters, lots of namespaces. And now we're talking about lots of small clusters, right? And, or lots of different environments for those clusters, right? Like I don't
And
necessarily want prod and dev living together, right?
exactly. And we've learned a lot about how when you have a lot of automation at play, what are good security boundaries? And one thing
Right.
that I think a lot of organizations, a lot of people using Kubernetes today struggle with is they have a lot of those abstractions they're building themselves, right? So that's just duplication.
Yeah.
Everybody using the same GitOps solution for CI/CD, awesome.
Yeah.
Everybody that wants to integrate into that CI/CD solution have to come up with new abstractions and new extension points, slightly less awesome. So there's ways that we can, I think I just call it, putting the community to work by looking for places where we're all doing similar stuff. And what are the bits that we can kind of supercharge by taking stuff that already works well? And this is the hardest part about Kubernetes. You can extend to Kubernetes and you can kind of make your problem more complex. I think we're at a point where we want to find out ways to extend, quote unquote, application infrastructure or flexible applications that are a little bit less tied to the cluster, right?
Yeah.
And that's going to be, you're going to have some people that you're going to have to pay a little bit of cost to change your apps. Ideally,
Right.
this is like how do you move forward, right? We didn't all start using containers in day one.
No.
People built bridge technologies. Sometimes containers were part of these new systems you adopted that you didn't even know containers were under there, right? The early versions of platform as a service used virtual machines or containers, and sometimes you couldn't tell which one was which. Serverless functions, depending on who you're running in, sometimes they run in containers, sometimes they run in micro VMs, sometimes they run in big fat VMs.
Yeah.
And this mindset is, I still think we want to be less focused on the how and look for places where open communities do this really well. Like Kubernetes has been hugely successful as an open community. There's no there's no czar of Kubernetes. There's a bunch of really passionate people who try to make the world better. It's pretty decentralized. Sometimes that means it's really hard to yank it around and to solve some pretty thorny problems.
Yeah.
But that still gives us room to say, but that's okay, because we're willing to give up on a little bit of 10-year roadmap style stuff.
Yeah.
Or looking for places where people actually need solutions or need the flexibility to build their own solution. So that's another characteristic I think we need to think about going forward is how do we make open source's perfect strength has always been, how do I take what you've done and build something else with it? Sometimes that's code when it's frameworks or libraries. And sometimes that's components, right? When you're pull together a Helm chart that has 700 components in it, you don't know how any of that works. And sometimes you pull in operators, or you've got a team that's using services from a cloud provider, and they're telling you've got to use the database service from a particular cloud provider.
Right.
What are the things that we're missing that make some of that easier, that help glue together these bits? There's a lot of great technologies out there in the ecosystem that kind of glue together bits of quote unquote cloud native applications. I actually think Kubernetes and the concepts around Kubernetes is a place where we could do that. Multi-tenancy within a single cluster is hard. We said before, if you've got all these different environments, can we use some of the same abstractions that we use, namespaces and clusters, but kind of lift them up a level, bring them up, and then plug in a broader set of integrations. So these are, there's a lot of stuff going on in the community, a lot of great investment in a bunch of different areas. One of the things I'm looking at is everybody's trying to solve a lot of these problems. How can I personally work with teams, individuals, companies, partners, clouds, competitors to say, we're all struggling to solve this problem. If this problem and this problem and this problem could be overlaid, could we all work together on that? So that's a little bit of what my day to day has been for a lot of the last 6 months to a year, is starting to think bigger than the current state of the ecosystem. Where can we create some alignment points and bring people together around projects that really accelerate the broad how do you deploy applications anywhere and use all computing to go do it. So
I think you drive home a few points that I always try to make when I'm talking about extending Kubernetes. And that is you have to use some of those Kubernetes native primitives and build on top of them, or else an API change is going to come along and ruin your day, right? And it could be in a minor release if you're not careful, right? It could be something very simple that just breaks for you. So staying Kubernetes native is important, but those primitives are primitive, right? For a lot of folks, right? So up-leveling that to make it more, not yet another abstraction layer, which sometimes people complain about, but a useful abstraction layer to something that is, do we want to care about which cluster is running which workload kind of thing, right? It is that pets versus cattle mentality. If all of your clusters are bespoke, artisanal clusters, you've kind of defeated the purpose of using Kubernetes, right? The idea is to make them very much replaceable, which has driven us to this where we're at with all these multiple clusters hanging out everywhere.
And people need the capability, right?
Yeah.
You never want to say, no, you can't use something like a service mesh, or you can't use a particular network plugin.
Right.
Because the moment you start saying, well, I'm going to stack this really tall, narrow path up of all of this, all these things have to line up perfectly, you start to get a little bit wobbly. So you got to broaden that foundation. And I actually think we're kind of in the broaden the foundation phase of containers and applications. We've got a huge breadth. You can go all the way from very granular functions deeply tied into your cloud into giant monolithic stacks of very specialized functionality where you may not actually even ever get to see the cluster. I think we're looking for places where we can kind of break down a few of those walls, stack those pieces, and get to that next level. There's a great sometimes we talk about the Unix way, right? So this gets trotted out a lot. You say the Unix way is lots of small composable tools. I think composable is important, but the better one is orthogonal. You have a bunch of tools that you can use independently or together to solve different problems. And the areas between them are actually pretty carefully chosen, right? So in Unix, you have the command line and you can pipe standard in and standard out. And you can chain together. But I don't know about you, I do tons of short chains and tons of long changes. And sometimes I say, you know what, I want you to take that chain and turn it into a program. So I move to Bash or Python and I start digging in. Those tools all work together. They have good orthogonality. Cube tries to have this, right? What are the concepts in Cube? Your services and pods. You've got where you're running and how you reach it. They're pretty separate. They don't depend on each other closely. It was it's a testament to a lot of the original folks in the Kubernetes ecosystem from Google's and others who recognized that that's a really key property of a powerful system. And so I'm, a lot of what I'd like to look for is places we can pick for more orthogonality. Why do I have to deploy everything in containers? I don't. Can I bring together some of my systems? And the Terraform project, is Terraform and Ansible together. There's a lot of people in those ecosystems who use a config management approach to deploying cloud resources and linking them together. Cube actually has a lot of similarities to that, but Cube adds that level of reactivity. And I'd say that's the difference. You have config management, and then you start running it multiple times and you have a loop.
Mhm.
And then you're in a world where once you have a loop, you start thinking about how you can be more efficient and what you can react to. And reactivity is the second step. So Kubernetes is a natural evolution at its core model of that loop, but it doesn't really have to be tied to running Linux processes or Windows processes.
Right.
And so there's a lot, I think there's some opportunities to say, well, like, what are the other config loops that people are doing today that if you looked at it, you'd be like, well, this doesn't fit Kubernetes. Well,
Mhm.
maybe what if we took Kubernetes and took away the machines? Does it fit? What if there was a more of a control plane for applications that was
Right.
a little, that had the powerful concepts from Kubernetes and
Mhm.
worked well with Kubernetes, but was a little bit less focused. Like containers are kind of the Goldilocks, right? They're the not too hot, not too cold, not too big, not
Right.
too small, not too
Yeah.
opinionated, not too flexible. They kind of sit in that middle.
Right.
Can we leverage that? Can we use containers as kind of the glue between the two extremes of the world, right? You have
Well,
big.
it's I'm sorry, go ahead. You have
No, please.
So I always looked at like Terraform and Ansible and that whole suite of configuration management tools as like the way, like the toolbox to glue or hammer or whatever, put all the things together, right? Like, and make sure that either the infrastructure was deployed correctly or the application was deployed on top of it correctly. And Kubernetes, like, you kind of stamp all that down into, often one, series of files, for lack of a better term. And oftentimes it can be one file. If your app is, simple enough and, just needs like a little bit of connectivity and off it goes kind of thing. So, having that natural evolution of like all of a sudden I've gone from, oh, I need 14 bits of Terraform or, 3 or 4 different things from Ansible Galaxy kind of plugged together with some of my custom bits of Ansible to now where it's more universally understandable in Kubernetes YAML.
Well,
It
Terraform
just makes for like a better standard, right? Like,
and Terraform and Ansible both are great examples of you're defining how you do the first creation
right.
and a little bit of how you do the second update or reconciliation. And you can do deletion and all that. I think it's really instructive to look at, when you add an Ansible module or a
Mhm.
Terraform plugin, it's about adding new abstractions,
Yep.
but there's no requirement that they be consistent. One of the goals, there's a certain amount of consistency, but for instance, if you look at one cloud provider's
Oh yeah.
Terraform resources and
Yeah. Yeah.
another's,
Yeah.
they're
Completely
not
different.
even, they don't always necessarily expose every capability, right? You have to
Mhm.
go write a mapping between the cloud provider API or a SaaS provider API.
Mhm.
SaaS providers, actually, not a lot of them have, they don't necessarily all have Terraform plugins
Yeah.
because somebody has to go do the work of taking an API,
Yeah.
and many times a fairly declarative API object, and stitching that in, coming up with a new abstraction for it. Right. So you take the API that the provider gives
The
you and
original
you change it.
abstraction. Yeah.
Right. So you have an abstraction on top of an abstraction. You got to keep that up to date, and you have to deal with versioning. I
Yeah.
think, and this is where I really have some optimism. If only we had some pattern that worked really well for declarative applications where you could decide what API you wanted and you can make it really easy to plug it in to that. And I
Mm.
think that the ease of plugin is there is nothing easier than writing a 500 line bash script to beat a problem into submission, right?
Right.
If if your solution isn't solved by one line of bash, just keep adding more until the
Right.
problem goes away, or you've got more problems.
Is that why it's called Bash? I forget.
It
No,
probably
I'm
is.
joking.
And it's funny in Kubernetes, Bash got us a very long way for
Yeah.
builds, and at
Yeah.
some point it becomes time that you start standardizing and formalizing the stuff that you're doing in Bash into something a little bit more rigorous. That's a really important step for most projects. It's very important for open ecosystems because for most things in an open ecosystem to thrive, a lot of people have to find them valuable, and they need to solve a problem well enough that you want to use it. So think of it like you're using something often enough that you start wearing down the edges. And I
Yeah.
think of this like the difference between a Terraform or Ansible open ecosystem for config management and creating cloud native things or manage them and what we can do in Kubernetes that adds that reactivity loop, but we can also help simplify the process of adding new things into Kubernetes, right? Like, why is it, if I want to adapt someone's SaaS API to Kube so that I can do a really quick and dirty application and do that, can we get to a point where we can make that easier than using Terraform or Ansible directly? Because after all, both the Terraform and Ansible ecosystems have really great plugins for Kubernetes that work dynamically. I'm really proud of the work that's been done in both those communities to deal with the abstraction and to pass it through without really having to modify it. The Kubernetes kind of provides that create, update, delete, reconcile loop, not perfectly, but well enough that if you can extend that, your Terraform script can still drive it. So for me, I think there's a huge opportunity here in the ecosystem to take those ideas of plugging all of it together, not just, containers, not just services, not just the one cluster stuff, but what if I want to program 50 functions on one cloud provider, tie it to databases, be able to use the provider's specific things when I need to, have some abstractions, put abstractions in place that most of us are using. And I think, you look around, if you looked at, I guarantee you looked at 100 cloud native application Terraform files, you find a lot of common problems that are solved perfectly well today that we can improve on and bring those closer to running applications in a way that starts to streamline and simplify a lot of that sprawl in the application ecosystem. And that gives us the more you bring together, the more you concentrate, the more opportunities there are for vendors and community members to say, you know what, if I've got a bunch of functions and I've got access to program some of these other interfaces, and I don't have to worry about some of the details of authorization, like if we can standardize some of that bit, that opens up doors for people to build really powerful integrations that might let you, for instance, do really trivial function deploy flows where the community works together to say, we're tired of solving this problem for 5 different ecosystems.
Providers,
Can we all do development of serverless functions in a similar way? Can we coalesce on APIs, right? There's a huge divergence of what the APIs for invoking functions are. Some of them are efficient, some aren't. Can we create centers of gravity that pull together application problems, encode those, and make those easy to support and sustain? I think is like a key goal of Kubernetes, regardless of whether you're talking about single cluster or the whole ecosystem.
Well, I think that's a wonderful point you bring up about the Kubernetes ecosystem in and of itself, right? Like before it forms a SIG, a working group, or anything else, right? Like there is a process that the decision tree kind of has to go through and say, all right, are we going to focus on this holistically as a project or ecosystem or community, however you want to phrase it? And, oftentimes you'll find that, right? Like working group LTS was stood up at one point and it was stood down, right? Like the idea behind a long-term supported version of Kubernetes is hard, right? Like for a community to maintain by itself. That's where folks like us, Red Hat, and other various vendors come in and we say, okay, fine, Kubernetes is this great, wonderful thing, but it's not just Kubernetes that you need, right? Like it's Kubernetes and nowadays. And I wanted to kind of touch on it's, folks are starting to often realize that they need a little bit more than Kube, right? Like it's just the beginning, not necessarily the end.
Everyone has way more than Kube.
Right.
Do you know where it all comes from? Do you know that it works together? And some of these are problems that, that open ecosystems, always have. Linux has been going through this. We have bunches of Linux distributions. We have lots of Kube distributions. There's a lot of things in Linux that standardize over time. And there's a lot of things that don't, like packaging. Doesn't stop ecosystems from being valuable, but I also think there's places where there's opportunities, there are opportunities in those ecosystems to build consensus and to align. I mean, the best part about Kubernetes is to go extend Kubernetes. You don't have to talk to a SIG. You don't have to get anybody to agree with you. Now, maybe if you're going to take the whole code base and change large chunks of it, you might want to think about the long-term supportability of that. But there's plenty of organizations out there that do that for things all the way from like Red Hat works with ecosystems all the time. Sometimes people want the latest and greatest. Sometimes people want stability for 10 years. Huge spectrum there. But the key goal is make sure the communities and ecosystems themselves are sustainable and growing. The more you can stay focused on that, the better. So like, yeah, I'd say like our stability is hard.
Yes.
But if you stay stable forever, that's also a trap. So,
Exactly.
again, it's how do you bring change in? So a lot of the thought around, where does Kubernetes go from here? Service v2 is a great example of maybe not something we could have done very early on or shouldn't have done very early on in Kube. But as a community, as an ecosystem, you got tens of vendors and projects and a large number of motivated organizations that are building and deploying around service mesh, ingress, complicated service scenarios that want some of these features, more than willing to help contribute, drive forward a standardization of some of the concepts that we didn't get quite right the first time, or some concepts that have evolved since then. But at the same time, you can still have alternate ecosystems for that and plug it in. So trying to thread that needle pretty carefully, like you want to centralize as much as you can. You want to solve the pragmatic problems you have, but then you don't want to fall into stasis, right? You never want to be the kind of project that's too afraid to change. So like, how could Kubernetes change? What are ways that Kubernetes can change? So I do think one is the, aggressively thinking about how Kubernetes patterns and model is applicable to a wide set of problems outside of a single cluster. That's one. Other ways are how you start to, standardize and solve application problems. That's necessary for that first thing. If you don't have a consistent way to talk across clusters or consistent way to say, what are the things that we've built in the ecosystem that don't standardize well? And Service v2 is a great example of that. We've done a lot of work with persistent volumes and the storage subsystem in Kube. There's a bunch of great things going on around making access to object storage kind of a standard thing. And it's half in Kube, half out Kube, because you have different needs, different requirements, but that model, it's still a little hard to do. And so this is, I think, the biggest challenge for Kube. It's hard to build meaningful standards that actually make people's lives easier. And it is much harder to do that as a group than it is as an opinionated individual.
Oh, absolutely.
So, especially when you have a good idea, you can drive it to completion. I feel like the most successful communities ping pong between those two. Creating open opportunities for people to redefine whole classes of problem. And then as people consolidate those, bring those back and move forward. Outside of, even Kubernetes, this is a huge problem for developer tools.
Yeah.
We have got plenty.
How many developer tools are out there solving the same problem, right?
And it's awesome too, because in the last 6 years, the number of people who've built simple and useful platform as a service type tools, right? Very opinionated in the vein of Heroku and the early days of the various PaaS efforts. You can still have opinionated flows. A lot of organizations build opinionated flows. When I look at the developer and application lifecycle or ecosystem, there's a lot of diversity and similarity that nobody's really attacked yet. And so that's another one that, and we were kind of alluding to this earlier, is I think the goal of Kubernetes as a concrete piece of software is pretty well accomplished. It's got to keep evolving. Can we create new ecosystems and new communities that consolidate the kinds of platforms and tools that make people more productive, all the way from, pure CI/CD, there's integrations into the large Git hosting sites out there. There's been a lot of interesting work, stay close to your code. And I actually think we're kind of in a spot where there's probably new opportunities for disruption there. Not every workflow has to has to be deeply integrated into your source code experience. What are the things that we can put into source code? So like infrastructure as code has been, kind of a hot topic around this. There's probably lots of other descriptions of the world that don't really fit into our source code workflows today that could be fit in, whether that's process or pipeline. We've gone through many iterations of those. Everybody's got a file they stick in their Git repo, or 10 files or 50 files. What are the common concepts there that new projects in the ecosystem could help pull together and make people's lives easier?
I mean, my dream ultimately is that I can create a quote pipeline file of some sort that says soup to nuts, right? Like if it's bare metal pointing at a server here in the house, or pointing at some API in the cloud somewhere, it's going to cover not just the infrastructure setup, but also the application pipeline development setup, and it's going to have the hooks and everything already glued together, right? So we're talking about Kubernetes, or not Kubernetes, but GitOps and secrets inside Kubernetes and how to manage that later on the channel. And like, that is a whole ball of wax in and of itself, because we're using infrastructure as code, right?
Well,
like,
and secrets are a great problem, which is not all secrets are necessary everywhere. If you can standardize, secrets are effectively a boundary between two systems where, the best solution we've come up with is, well, I'll just hide some data over here and hope that everything goes well. One of the things that I think, in the Kubernetes ecosystem and the broader application, and nobody's really tackled, is within a cloud, there's a lot of really interesting opportunities to force standardization on a particular identity technology. There's a lot of open.
If you could solve IAM with something standardized, please, for the love of God, do it. Right?
And service mesh took one of those steps within Kube, right? Service mesh kind of said, can we tie identity and interconnection closer to the application?
Yes.
I think we're just at the beginning of kind of those. Is thinking about moving to multi-cluster worlds, tying in cloud. If you're running an application that's tying into the cloud, you may actually want, and again, like this depends on who you are. Everybody wants something a little bit different. As we standardize more on authorization and identity interfaces, as we standardize more on application infrastructure abstractions, like whether it's service mesh or injecting secrets into your workload, can we actually build out some of those open source glue projects? And there've been a few in the community that, for various reasons, haven't always exploded into wild adoption. Can we smooth those paths to kind of standardize those? Like for us, identity would be a great one. Single sign-on, tying cloud to everything else. So what if you'd like to have some flexibility in how your IAM implementation works, but you want many of the same guarantees that you could get from a cloud provider? I think there's a lot of opportunity in open source projects out there to work closer together and to help standardize on those. Like, concentrate some of this. Like if you've made a bet on Kubernetes, or if you have a particular serverless implementation, why is it so darn hard to get data from one to the other? Looking at ways that we can both make that open, right? So not everything's going to run in one cloud or on premise or on your laptop. Is your laptop going to be tied into a cloud identity system? Some people might. You're definitely tied into your organization's identity system.
Right.
How can we start to build things that make that easier for developers across the board?
Oh yeah, no, I mean my last few ops jobs before I joined Red Hat were very much right. Like, okay, I've logged into the quote network or domain, and now I have to log into my cloud providers, and there was various steps involved in doing that, right? And Okta and everything else. It all came back to our single sign-on, but yes, it was all glued together through a service, and it was a pain, right? So like, it is what it is. It's gotten better over time, obviously, but like having that capability becoming a standard would solve more problems than I think people realize, right? Like,
And there's a lot of that integration glue that's still hard or ugly, and we do it different
Mhm.
ways, or we throw a couple hundred lines of Go code or Python or Rust or C or Java or C Sharp. But we throw code together and we hope it doesn't break on us. Most of that code as written probably will never get changed. I think, something that Red Hat as an open source company who's very interested in making developers and operations teams' lives easier is to be able to stay focused on those kinds of abstractions and just over time help the communities, help bring individual projects together, keep a little bit of relentless pressure, right? Open source is a little bit like the ocean, right? We all use it.
Yeah.
There's not a single person I know of who doesn't use some open source
Right.
in every bit of their day-to-day interactions.
Yeah.
It's only becoming, more broader and more useful. What are the ways that that ocean of open source can wear down some of those rocks of just the really ugly stuff? Like, how can we slowly move in the direction? And the great thing is that most people's incentives align towards this, right? Like, this is what
Yeah.
if you're a developer and you can hack on something that you put on on GitHub or on some other site that
Mhm.
that brags about how much you improved your dev workflow. Someone will go do that. All
Oh,
of
yeah.
us will go do that because it
Yeah.
makes our lives more easier. Trying to look for places where we can spot those, bring them together, and help wear down some of these ugly integrations, I think is really like, this is what our job is.
And that bears the question, right? Like, how does the Clayton Coleman ugly spotlight identifier work, right? Like, how do you go out and find those problems that you want to like standardize and help people solve in a greater way, right? Like, it's not a bad signal. I know it's hard to find them.
It's interesting because when someone puts a solution, and this is the nice thing about open source today, and some of the broad accessibility we have to see what other people are doing in the open source ecosystem, whether it's in one ecosystem or in another, most of the good ideas someone's had, most of the problems are already out there. Someone has a solution. If you spend enough time looking at what people are trying to build, and this is always the hard part, is it takes me, 1 unit of effort to hack together a bash script or a single chunk of code that solves my problem.
Right.
It is 10x or 100x or 1,000x harder to take that and find and make it generally useful.
Right.
That's where a lot of open source kind of dies. It's something that's useful for me.
Right.
But when you start having 10 or 15 of those examples, you do often get a pretty good idea of what. So, I spend a lot of time, like, especially in this discussion about multi-cluster, I spend a lot of time, reading and looking at what other organizations are doing, whether they're contributing to the multi-tenancy working group in Cube, right? There's
Right.
a lot of prototypes, a lot of really passionate people. We've probably generated 150 ways to do aspects of multi-tenancy. I think the research is done by the open source community. That's the best part
Yes.
about it. It's
Yeah.
both
Yeah. Yeah.
useful and they're willing to share it. You can learn a lot by seeing what problems people are struggling with.
Yeah.
And when you have a lot of solutions that none of them really take off, you really can look at that combo of those things and say, well, what's the thing they all have in common? Why
Right.
hasn't that succeeded? And
Yeah.
sometimes it's you're not changing the problem domain up enough.
Oh.
Sometimes it's there may be no local minima, and you'd say like, okay, well, if we have 10 of these, surely there's one. Well, there is, but it's 10 times the work, and it doesn't
Ooh.
really
Yeah.
give that opportunity. So I do think there's I'm sorry, in the future of computing, we're still going to write ugly, hacky integrations to glue stuff together, and that's okay. I've learned
Well.
that over my career is
uh,
it's okay to make ugly things that solve your
yeah.
problem.
Right.
The goal is not to be pretty. The goal is to get the stuff running and for people to be happy on the other end. So like,
Right.
that helps me, is like, I spend a lot of time looking at what we're doing and saying, if I take myself outside of the
Mhm.
particular problem space we're in, what does someone actually want? And a lot of times, where we go invest at Red Hat, where people who are in the community, sometimes it's someone will have a great idea and they'll casually mention it. And someone else will have a very similar idea. I've actually found more and more that if you spend a lot of time listening, you actually don't have to do as much thinking as you would expect, because most of the good ideas are out there. It's actually the synthesis of it that's actually the hard part. And you don't need a ton of people doing that, but like it's the, how do you pay attention to what's going on in the community? Look for areas that, where a little bit of consolidation or coordination could make those bridges. And that's kind of how, like, in my day-to-day, that's really all I'm doing is trawling GitHub and talking to a lot of people, and then trying to boil that back down into, well, what are all the things that we're all thinking that will help us move forward?
So we do have a question in chat. Is there any plans in the future for automating cluster backup, which I think is interesting because we talked about pets versus cattle a little bit earlier, and PVC backups and integrating it into the cluster or the UI itself, somewhat similar to what Valero does. And there's a lot of cluster backup solutions out there, and there's a lot of ways to back up PVCs, but none of it has become like a de facto standard, right?
This is, so I'll say, this is one of those areas that we're all looking for a local minima, and we haven't quite found it yet. Valero is a great project. It does some things really well, and it struggles with other things. I think so there's two dimensions of this. The PV abstraction has helped us think about the problem differently. So snapshots, and we don't always get these perfectly, but the PV is a thin reference to something underlying. I think one of the things we're really lacking is the backup use case is pretty clear. A lot of people that I know do backup on a whole cluster at a time. Because it's easier. I think one of the challenges would be 10 years ago, I don't know that we would have thought about backing up every single hard drive in an organization.
Couldn't do it.
Every 6 hours. So there's a lot of places where, as the technology for backup and the underlying infrastructure has gotten better, we've been able to use that. I know there's a number of backup people in the ecosystem who are doing very similar smart things for us, OCS and Ceph. I think there's a lot of room for that in an on-premise setting, in the cloud. I actually kind of think that the best solution really is going to be something that you can't fix every application. So, how do you make every application crash safe? Well, first off, if you want to make every application crash safe, you build a container platform that crashes a lot. And you teach people that you have to think about crashing. So that's like, there's a little bit of, as we've gotten better over the years, I worked on applications early on in my career where the thought of crashing and crash safety was, oh, that's interesting, but yeah, don't worry about that. Kubernetes builds into its very premise, things crash and die, and we don't always do it cleanly. We spent a lot of time in the early days of Kubernetes, like, wringing our hands about whether people could run Postgres instances on Kube if we didn't get the shutdown model correct. And the answer is you can. And if you know what you're doing, you're fine. And it's still possible to shoot yourself in the foot because you still have
absolutely.
So crash safety is really hard. I don't think we'll ever get all applications to do backup exactly, but by creating these abstractions that kind of put a certain mindset in place, which is you write to disk, and if you want to do backup, the only way that you're going to be able to really easily back up is snapshot the disk. Some of those problems sort themselves out. Call it open source evolution, is if you can put the problem in front of everyone, they start to hit it. So will we build solutions that make backup easier? Absolutely. Will we help build abstractions that do that? So persistent volumes and bucket claims are great examples. I think there's, we were talking earlier about abstractions for services. I didn't really get into this, but a pattern that I've noticed every organization have is if you're building something for a large set of developers, you try to standardize on an actual interface. And for a lot of people, that's a SQL connection, or an object storage bucket, or a file system, or an event stream of some form, whether it's an older message bus or something like Kafka or something like a cloud, an append-only log with some read semantics. I see the ecosystem kind of aligning on that. One of the things that I think would be a great opportunity is, while we might not ever get a magic backup integration that does all applications equally, if we make it easier to do SQL-like abstractions, right? Not too generic. Give me an HTTP connection, has its own problems, works for web services, but not others. And it's not a super low-level integration, built into every framework. But if you can find those right points of abstraction, and you could say maybe represent a type of database. And again, like, it's not just generic SQL. Differences between SQL databases matter. But if you can say things like, I need a Postgres compatible database schema that most of the time, I'm dealing with a database or a set of tables or a schema. Some of those abstractions don't really exist today. If you think about extending and lifting the persistent volume abstraction up, wouldn't it be awesome if you could represent a database with a cube object and have it say, this is an instance of a database, and it's materialized, and I can also connect to the idea of initializing it, or in my app, getting access like some our deals. But if I could snapshot that database at a point in time, and the cloud vendors have options like this, newer databases, Postgres does, but things like CockroachDB have the concept a little bit like what etcd does of, I want to snapshot my database at a particular time. You can take a consistent snapshot and back it up. There are interesting opportunities there that we haven't really explored yet. Still pretty early, that I'd like to see. A concept of a database opens up a bunch of new topics. Doesn't mean everybody's going to use it today. It's easier just to go, pull in the credentials and stick them into a file and stick a secret there. The important thing about every abstraction that we put into Cube is it has to be just as easy as the stupid thing and more useful, because nobody switches from the easy. That people will write bash till the heat death of the universe, and people will copy secrets and connection strings and just, write passwords on their
sticky notes,
sticky notes, and put them on their monitor until the end of time. What we have to do is actually make the abstraction useful enough. And Cube did this, right? Cube made the service abstraction useful. It made the pod abstraction useful. Almost every successful software project has some abstraction that was similar to what you were doing before and easier. Ruby on Rails, if you're building a website for a client, Ruby on Rails dramatically swept the ecosystem because its center of gravity was so much lower. Cube did that for the container ecosystem. I think, in the whole backup story, we're looking to put abstractions in place that kind of lower the friction point. So, I'm just going to hypothesize for a second. If you want to move an application around, you got to move the data around. And sometimes moving lots of data is hard.
There's physics
and sometimes
involved.
There's physics involved. There's politics involved, and there's money involved, all of which are very difficult. Politics, money, and physics. I'm not sure which of those is hardest.
Like those are all three very interesting. Like, I'd never thought of it like that, but that's very, very difficult problem to solve.
But, what are some advantages that if we could standardize some of the data side across multiple clusters is, there's people today who can do backups of PVs on a whole cluster. Awesome. We might want to introduce abstractions that make backing up applications. Awesome. If we can create the opportunity for more people to use these abstractions by kind of getting even more of the application development experience to be Cube-like, but maybe not Cube-centric, right? Not depending on a cluster. Can you actually say, if everybody who is doing a Terraform script today to deploy these big complex cloud applications could do that through like a Cube-like control plane, some of those abstractions become more valuable. If we can create that imperative in the communities and work with the ecosystems and look for ways of growing Cube and growing extensibility and improving Terraform and helping backup vendors with some of these good abstractions, we all kind of end up in a better spot. But if you want to move that app across two clusters, You either need to know that that data is sticky and ain't going anywhere, in which case moving the app doesn't do much good.
Yeah.
You might need to tunnel it. You might need to copy it. And this is like, there's like some super painfully easy things that we haven't standardized in Cube yet, but almost everybody I know who's running in a big on-premise setup has 2 clusters or 2 data centers, close proximity.
Right.
Active passive across 2 Cube clusters is insanely difficult to standardize today.
Oof.
But why don't we? Like, there's nothing, it's just most people don't have enough of the same problems that everybody's problem lines up. The thing I'm really focused on is like, how do we get those problems to line up? So for the backup thing, can we get persistent volumes and backup persistent volumes tied to apps and orchestration across clusters? If you can orchestrate across clusters, that's one dimension of the problem. It also gives people building in the ecosystem a better handle on applications themselves. Because today applications are kind of tied to a Cube cluster, right? The best, a lot of the trivial ones aren't, but there's assumptions that get baked in. If we can make like those assumptions a little,
has something that other clusters don't, kind of thing. Yeah.
Exactly. And if we can do a better job of standardizing some of those assumptions, it makes backups easier, right? Everybody's kind of talked about this for years. It's like, if only we had the concept of an application. There's no such thing as the concept of an application. There's the environment and the abstractions you use to build your application. If we can concentrate that, if we put more of that together, we actually can increase the value of building those integrations. So it's a really long-winded way of saying yes, while continuing the previous points of like, our mission has to be broader. Like Red Hat, and certainly like, I'm not going to build the best backup solution. Red Hat is not necessarily going to build the best backup solution, but the ecosystem, motivated vendors, Red Hat users all have most of the partners, cloud providers, all have many of the pieces that we're all dependent on, right? Like this call right now is dependent on so many layers of technology. It's probably, it's terrifying.
It is dizzying.
Our job is to collapse a couple of those layers, make it easier, and keep doing that through Cube and other ecosystems.
And it's funny, right? Like, for producing and making this channel, we say we have moved the complexity to the seat of the producer, right? Like, in any big software project, you're moving complexity somewhere, right? And like, we've realized that like, for this channel, we need to have the complexity sit with, me or someone like me. And for a Kubernetes like federated system, that complexity has to live with something. And is it the scheduler? Is it the kubelet? Where's it going to sit? And where's the best place for it is the hard problem.
The transition from the previous world, which is runs on my machine, is works from my Terraform execution. And it is not a knock on Terraform.
I don't know why it doesn't work on your system.
And it's not a knock on Terraform. We're just not doing enough, comprehensively, and comprehensive is hard. So let me say this: we are on a path to try and bring these things together. Is Kubernetes going to be the thing that we all use for the next 30 years? I don't know. Are we going to have all of the things that we're using now plus 10x more? Absolutely.
Yes.
We have to continuously be thinking about how we simplify. And that simplification is take those concepts that really work, double down on them, and let people hack around the edges, because that's how you get real work done.
And I think Kubernetes has done a lot of, quote, democratization and a lot of bringing sometimes opponents, like together, right? Like, Red Hat and Microsoft are working on Kubernetes. We weren't always best of friends, but now it's all good because we see this opportunity to work together, right? We see opportunities across the industry where we hadn't before Kubernetes came along.
And open source has gone through this transition too. I think the early days of open source were very pragmatic on people had a very strong connection to the stuff they run, and the world was these little islands of walled off knowledge, and you went from company to company, and You had to relearn everything.
Relearn everything, yeah.
And so those initial communities grew by, controlling it all, controlling the whole ecosystem. But now we're in a different phase, right? Open source is not just individual contributors; it's people trying to get their job done. It's companies who exist solely to offer a solution, and they know that open source is fundamental to their story. They can't avoid having something open, even if they have closed elements.
Right.
And you can't succeed in open source today. You can't succeed at programming unless you can figure out how to come up with win-win scenarios. And like this is the open source was kind of the biggest win-win of all, which is I take stuff and you can use it. Huge win-win.
Yeah.
The next hard problem was how do you and I both try to fight to get value out of what we're doing? The startups have done this for a while. Red Hat's seen this, come and go. All the cloud providers are jumping on this. We love open source, and the reason is because everybody who works at those companies who's come up in the last 30 or 40 years almost certainly uses open source in their daily life. So it's like it's changed from being something we're not fighting to get open source accepted.
No.
What we're trying to figure out is how all of us work together in a win-win fashion versus a zero-sum game, right? Like I win, you lose. That's a hard problem, but that's actually the important problem, right? Because I can't make you do anything, but if I can set it up so that you and I both benefit together, we're all better.
Yeah, it's like I tell people, I can't change people's behaviors, but I can certainly make suggestions that are educated, right?
And understanding what someone's trying to achieve. Spending 5% of your brain cycle, like open source is about spending greater than 0% of your brain cycles figuring out how what you're doing as a person is useful to someone else, putting yourself in their shoes and trying to build it. And I think that's why, Cube is successful even without that very centralized, control and vision, because we don't necessarily at this point in the project need these wild outgrowths of complexity.
No.
But we do need people who are willing to stick it out and to think through what everybody else is going through and to contribute. And we can still have those crazy flights of experimentation in the ecosystem. And then it's that process of understanding what the problems were. So tying that back into the larger system and the larger problems we're trying to solve.
Yeah, it's all about problem solving when it comes down to it, right? And doing it together is oftentimes easier than not. So that is the beauty of open source. So we only got about a minute left, Clayton. Is there anything else you want to say or, parting words for folks?
I am incredibly privileged to have been working on OpenShift and in the Kubernetes community, in the container ecosystem, in the Linux ecosystem, in the open source ecosystem in general. I want to thank everybody who contributes, uses, feeds back, thinks about other people's problems, and takes that greater than 0% thinking about how you can help move all of this forward, because none of this would be possible without everyone else.
Absolutely. And I think that's the best way for us to end this. Thank you, Clayton, for joining us. Thank you, everyone, for watching. Please tune in next time, which is in a couple weeks, for hang on, when calendar opens. Never mind, calendar's not going to open today. Okay, fun. Thank you, calendar, for being so helpful. Joe Fitzgerald is the next person coming up here in a couple weeks. So thank you, Clayton. Thank you, everyone, and we'll catch you next time.